and welcome to Agora Math Circle. Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel. This is Junior Advanced and we're going to be learning about angles. So let's get started. So angles are measured in degrees, which look like this symbol right here. So if we were measuring 90 degrees, it would be 90 degrees like this. Now let's go over some types of measurements that you will see. And let's start with a full circle. Now, you know what a circle is, obviously, right? And it's measured in 360 degrees. So the whole thing is going to be 360 degrees. Now let's go to a straight angle, which is 180 degrees. Now, straight obviously means a straight line or something like that. So let's say this is our line. So instead of it being like this, it would be straight and measured 180 degrees over here, like this. Now let's go on to a right angle. Now we already talked about this, I'm pretty sure, but a right angle is when this is measured exactly 90 degrees, and this is shown by a square that is drawn in the area of the degree. So here's a bigger model. So this would be 90 degrees. Now let's go to an acute angle. An acute angle is less than 90 degrees. So, as we said, this is 90 degrees. So it can even be 89 degrees, it can be 89 degrees, can be even 12 degrees. But it has to be less than 90 degrees. And let's go on to obtuse angle. An obtuse angle is greater than 90 degrees, but obviously less than 180, since a straight angle is 180 degrees. Now we know that this is a right angle, so obtuse can be all the way up to 91 to 179. So let's be more specific. 91 degrees to 179 degrees. So it can vary from these degrees. So now you know about some specific measurements. Now let's move on to polygon, starting with polygon vocabulary. So let's move on to what a polygon really is. A polygon is a figure that can be drawn using only straight line segments. So an example of a polygon would be a square, since it has only straight lines. Now let's move on to the next word. Perimeter. A perimeter is basically the distance around a shape. So it would basically be, if we looked at a square, it would be this side plus this side plus this side plus this side. Nothing inside the square, only around it. So say all of these distances were named as S. So it would be S plus S plus S plus S, since a square has equal sides, or equal lengths and sides. So it would be for S. So now let's move on to area. So area is measure of region inside a shape. So unlike perimeter, which is around, we're actually looking at what's inside. So this shaded area here would be the area. So now let's move on to a type of polygon. And so a triangle is a polygon with exactly 3 sides. And I'm pretty sure all of you guys know how a triangle looks like, but just in case I drew it over here. So it has 3 sides. Now let's move on to the types of triangles there are. So we have a scalene triangle. And a scalene triangle is basically where it has no sides of equal length. So I drew a scalene triangle here. So as you can see, none of the sides have equal lengths. This one's actually a little shorter than this one, in case you guys think that these two are actually of equal length. Now let's move on to an isosceles triangle. And an isosceles triangle is basically where 2 sides are of equal length. So I'm going to draw an isosceles triangle here. So I'm going to draw these 2 lines. This means that these 2 sides are of equal length. So now you guys know about polygon vocabulary. Now let's learn some more vocabulary words based on polygons. Let's start with an equilateral triangle. An equilateral triangle is a triangle that has 3 sides of equal lengths. Let's draw it out here. So if this is our equilateral triangle, then all of these sides are equal. So they have the same lengths and sides. Let's go on to a quadrilateral. A quadrilateral is a polygon with 4 sides. And you know this because it has the word quadra in it, which means 4. So an example would be a square, a rectangle, a parallelogram, a trapezoid, a rhombus, and so on. Now let's go on to a trapezoid. A trapezoid has 1 pair of parallel sides, and the other pairs, if it's not parallel, then it's going to intersect at one point. So let's say this is an example of a parallel trapezoid. As you can see, this is parallel, but these two, if it keeps on going, at one point it's going to intersect. And that proves that this side is not parallel. Let's go on to a parallelogram. A parallelogram has 2 pairs of parallel sides. So unlike a trapezoid, which has 2 sides that are going to intersect, all of the sides are parallel. And it usually looks like this. Although there are various forms of parallelograms, such as rectangles, this is the most common one, and this one does not have any right angles. However, a rectangle is also a parallelogram which has right angles, which we will learn about now. A rectangle is a parallelogram with right angles, and not all sides are going to be equal. However, these 2 sides are going to be equal, and these 2 sides are also going to be equal, but all of the sides are not going to have same length. However, each angle is going to be right, meaning it's going to be 90 degrees. However, there is a polygon that has all same side lengths and same angles, which is a square. A square is a rectangle with all 4 sides of equal length and all right angles. And it looks like this. So all of the sides are equal and they all have 90-degree angles, or a right angle. So now you know about various forms of polygons. So now let's learn about perimeter. Now perimeter is basically when you add up lengths of sides to find the area around the polygon. Now let's look at some examples. The first one has sides of 3, 4, and 5, and it says to find the perimeter. Now it says that the perimeter is when you add up the lengths of the sides, and we know that the lengths are 3, 4, and 5. So we know that perimeter, which is P, is equal to 3 plus 4 plus 5. Now 3 plus 4 is 7, and 7 plus 5 is 12. So the perimeter is 12. Since it didn't give units, we will write it as units. Let's go to number 2. Well, it says that it has lengths of 4, 4, L, and L, and the perimeter is 18. Now we know the perimeter is the sum of all the lengths. So it's 4 plus 4 plus L plus L is equal to 18. Now 4 plus 4 is 8. And L plus L is, well, 2L and 18. Now to solve this equation, what we have to do is bring the variable L on one side. So we subtract 8 and subtract 8 and we get 2L equals 10. Now this might be a little complicated, but what we do in this equation is, we know that there's a 2 over here times L equals 10. So what can we do to bring this L, only this L on this side, and the rest of the equation on the other side? Well, we know that 2 times L is equal to 10. So we can divide by 2 to get 1 times L is equal to 10 over 2. So L is equal to 10 over 2, which is 5. So we know that L is equal to 5. Let's write that down over here. Finally, let's go to the third problem, which is L plus L plus L. And the perimeter is 24. And it's asking for what L is. And it says that it's an equilateral triangle. And we already know that because the variables are the same for each of the sides. So we know that there's 3 L's. So it's L plus L plus L. And the perimeter is the sum of all lengths, even for triangles. So it's L plus L plus L equals 24. Now L plus L plus L is nothing but 3L, since there are 1, 2, and 3 L's. So it's 3L equals 24. And once again, we do the same thing that we did in this equation. Bring L to one side. And you do that by dividing the coefficient, which is 3. This might be a little complicated, but later on you will understand it more easier. So you get 24 over 3, which is 8. So L is equal to 8. So now you know more about perimeter. Now we talked about perimeter, now let's talk about area. Now today we're going to be learning about the area of rectangles, triangles, and trapezoids. Let's start with a rectangle. The area of a rectangle is equal to the product of the two adjacent sides, meaning the height and the base. So the area is going to be B times H, or the base times height. Let's do an example together. Let's say that the height is 4 and the base is 8. Now, based on this, what can we conclude about the area? Now, the area is base times height, and the base is 8, and the height is 4. So, the area is 8 times 4, which is 32. Now, let's go on to triangles. Now, to solve for the area of the triangle, well, there's two ways. Well, let's say there's a triangle like this that doesn't have really a height. So you would take the middle of it, and that would be your height. And this would be the base. And for both of them, including this one, let's say there's a right triangle like this. Let's say this is right. It doesn't look like it's a right triangle, but it is. So it would be height times base. So to solve for the area, all you have to do is a half of base times height. So let's say that the base is 3 and the height is 2. Well, all it would be is 1/2 of 3 times 2, which is, well, you can cross cancel over here because there's a 2 in the denominator and the 2 in the numerator, and you get 1 times 3, which is 3. Now let's go on to trapezoids. Now, trapezoids are very odd. Now, the thing is that a trapezoid has 2 bases, base 2 and base 1, but only one height, which represents this and this. So the area is base 1 plus base 2 over 2 times height. So what we're basically doing is calculating the average of both of these heights and then multiplying it to the height. So it's average of bases times height. So let's say that B1 is 5 and B2 is 9. And the height is 6. Now what can you do with this problem? Now I know that area is B1 plus B2 over 2 times height. And B1 in this case is 5. B2 is 9. And since we're calculating the average, you divide by 2 times 6, since it's times the height. So 5 plus 9 is 14. So we know that this is equal to 14 over 2 is 7. 7, so 7 times 6, which is, well, 7 times 6 is 42. So the answer is 42. I hope that from these problems you know how to calculate the area of a rectangle, trapezoid, and triangle. Now let's look at a practice problem based on what we learned on the formulas of areas and perimeters, such as triangles, trapezoids, and rectangles. Let's start with this practice problem we have over here. So let's read the practice problem. The floor of Sam's bathroom is covered with tiles in the shape of a triangle, has a height of 7 inches and a base of 12 inches, and this is for each tile. If the floor has 40 tiles, what is the area of the floor? So let's go ahead and find the area of just one tile. And we know that that the tile shape is a triangle. So let's go ahead and draw a triangle here. So we know that the height is 7 and the base is 12 inches. So we know that the area is base times height divided by 2. And we have the base and height here, so all we need to do is go ahead and solve so that we know the area of just one tile. So we get area equals 7 times 12 divided by 2. That's 84 divided by 2, and 84 divided by 2 is 42. So we know that it's 42 inches square. So this is for one tile, but we need to find out what the total area is for 40 tiles. So that means we have to do 42 inches square times 40. Let's go ahead and do that. I'm just going to do it really quickly over here. And we get 160 and we add a 0. So we get a total of 1,680 inches square. And this is for 40 tiles. So that's our answer. Now let's move on to circle. So what's a circle? A circle is a figure consisting of all the points in a plane that lie at a fixed distance from a particular center point. Now let's move on to some of the parts of a circle. Let's start with the radius. The radius is the distance from the center point to any point of the circle. So the center point, we know, is about here. So it's from the center point to any point. So it could be to here, it could be to here, and so on. Now let's move on to the diameter. The diameter is the length of the longest line segment that can be drawn from a point on the circle to another point. So it's the length of the longest line segment. And we know that the longest line segment in a circle can just be a straight line like this. And it can be drawn from a point on the circle to another point. So it's basically like this. And the diameter is equal to 2r, or 2 times radius. And this is because we know that the radius is just from here to here. So that's radius, so that's one radius. And then here we have another radius. And r plus r equals 2r. So that's why the diameter equals 2r, or 2 times radius. Now let's move on to the circumference. And the circumference is basically the distance around the outside of the circle. And another word for circumference could just be the perimeter. It's basically the perimeter of the circle. So to find the circumference of a circle, it's basically all you need to do is 2 pi r, or pi d. And pi is approximately equal to 3.14. Although when we're solving, we usually don't need to solve using 3.14. We could just keep it as pi. And so the circumference is 2 pi r, or pi d. And the area of a circle is pi r squared. And this is what you need to know about a circle. Now let's do some practice problems based on what we learned about circles. Let's do the first one. What is the circumference and area if r is equal to 5? Write in terms of pi. So let's first draw it out on this circle. Now, we know that the radius is 5. So r is equal to 5. Now let's first try solving for area. Now area, as we know, the formula is pi r squared. Now in order to solve, we need to know at least one of these variables. However, we do know what r is. R is equal to 5. So pi r squared is equal to pi times 5 squared. Now 5 squared is nothing but 5 times 5, which is 25. So the answer is 25 pi. So we know that the area is 25 pi, but let's try solving for the circumference. So the circumference, the formula is pi d, or 2 pi r, but I think pi d is easier. Now we know that the diameter is equal to 2 times r. So the diameter, which is the whole thing, is 2 times r, which is 5. So the diameter is 10. So the circumference is pi times 10, which is equal to 10 pi. So we know that our area is 25 pi and our circumference is 10 pi. Now let's go on to the second problem and erase this. Now, what is the area and circumference if d is equal to 6? Now, we know that d is equal to 6. So this whole thing is 6. Now, before starting, we know that the radius is important to solve the area. So we know that d is equal to 6, and d is also equal to r. So we know that 2r is equal to 6. So the radius, is just 6 over 2. So r is equal to 3. So this part, which is half of the diameter, is 3. Now let's first solve for the area. The area is pi r squared, as we said. And we know that r is 3, so the answer is pi times 3 squared, which is 9. So our area is 9 pi. Now let's go on to the circumference. Now the circumference is pi d. And before doing anything, we already know what d is. D is 6. The diameter is 6. So we can simply plug it in and get 6 pi. So we get the area as 9 pi and the circumference as 6 pi. So I hope you understand how to solve for the area and circumference of a circle.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!